As you write more code, you may run into situations where you need to convert data from one type to another. This is also called casting. So let's look at a few examples. I'm going to declare an integer called x and set it to 1. Then I'm going to declare a double called y and set it to 2.2. Next, I'm going to declare another double called z and set it to x plus y. So note that here, we're adding an integer to a double, okay? Now, if we print z on the terminal, what do you think we're going to get? Let's find out. So we get 3.2, which means our program behaved exactly the way we expected. But let me explain what happens under the hood. In this case, because we're adding an integer to a double, the compiler automatically converts x from int to a double, so this expression can be evaluated. So under the hood, the compiler promotes x from an integer to a double, and this is totally fine because doubles are more precise and take more space than integers. So converting an integer to a double doesn't result in data loss, okay? However, if we change the type of z from double to int, we're going to encounter data loss. And that's why we have a warning here. Let me explain what is happening under the hood. So just like before, the compiler is going to promote x from an int to a double so it can evaluate this expression. The result of this expression is a double. Now we're trying to store a double inside an integer, which is a less precise type. It has less space. That is why we may encounter data loss. Not necessarily, but we may. Let me explain what I mean. So if we run this program, we see 3, so the fraction part is gone. However, if y was equal to 2.0, in this case, we wouldn't lose data. So data loss may or may not happen. That is why we have a warning here, okay? Now, in the situations where we might encounter data loss, it's a good practice to explicitly tell the compiler that we want to convert a value from one type to another. Basically, we want to tell the compiler that, hey, I know what I'm doing. Trust me, don't give me a warning. Now, in this case, we have to convert or cast y from a double to an integer. So 2 integers can be added together and stored in z, okay? How can we do this? Well, there are 2 ways to convert or cast y to an integer. One way is what we call the C-style casting. So just before y, we type a pair of parentheses, and inside the parentheses, we specify the target type, which is int. This is called C-style casting. Now, the problem with this approach is that if conversion cannot be done, we will not know until we run our program. So we have to run our program, test all its features, and then if the conversion cannot happen, we will encounter a runtime error. There's another way that we can catch these kind of errors at compile time. And with this, we can simply compile our code and we don't have to run it and test every feature to see that some conversion can be done or not. This is called C++ casting. So instead of prefixing our variable with the target type, we're going to use the static cast operator. After this, we type angle brackets, and inside the brackets, we type the target type, which is int, and then we call this like a function. Okay, this is called C++ casting, which is safer than C-style casting. With this, when we compile our code, if conversion cannot be done, the compiler is going to tell us. Okay, so this is all about casting. Now I have a little exercise for you. Let me delete everything here. I'm going to declare 2 integers, x and y. Now let's declare a double and set it to x divided by y. Now if we print z, we get 3 because we're dividing 2 integers and the result of the division is an integer. Now here we have a little warning. How can we change this code? So the result of this division is a double value. Pause the video and think about it for a few seconds. It's really easy. Okay, here's the answer. As I told you before, to force the compiler to perform a decimal decision, at least one of these numbers or one of these operands has to be a decimal value. So in this case, we can convert or cast either y or x. We don't have to do both of them. Just one of them is enough. So we can do C-style casting, which is not recommended. Instead, we're going to do a static cast. So static cast of double, and here we pass x. Okay? The warning is gone, and if you run our program, we get a decimal value.